Group 6 from Physics 6. Today we're going to talk to you about magnetic levitation. So as you can see behind me is an LRT track. Like all other train stations around the world, it is a vital link for people to carry on about their daily lives.
But as we strive for a quicker future, our trains can no longer transport us in a quick and efficient way.
The problem? Friction! The solution? Magnet!
Faraday's law describes how an electric field can be induced by a changing magnetic flux, or in other words, it describes about the induction of electric current. This law is invented by Michael Faraday, who has discovered that magnetic fields do induce electric current, but only when the magnetic field is changing with time. This law states that the electromagnetic force induced in a circuit is directly proportional to the time of rate of change of magnetic flux through the circuit. Faraday's law simply states that if a closed loop of wire is placed close to a permanent magnet, then electric current can be induced into the wire by moving either the magnet with respect to the coil or vice versa. Hence, it is the relative movement between the coil and the magnet that matters. When the magnet is moved towards the loop, the current induced flows in one direction, but when it is moved away, it flows in opposite direction. This indicates that the direction of the current depends on the time rate of change of the field. For example, if the field is getting stronger or weaker as time progresses, the direction of induced current is further explained by Lenz's law. By the way, I'm having fever now because of iCaron.
Lenz's law describes about the direction of current being induced by magnetic field as described in Faraday's law. It states that induced electromotive force generates a current, which flows in such direction as to induce a countermagnetic field that opposes the magnetic field generating the current. The induced EMF creates a current that itself creates a secondary magnetic field. This secondary magnetic field also changes with time and thus creates a changing secondary magnetic flux. The secondary flux changes in such a way to oppose the change in flux, creating the EMF. Magnetic levitation can be further understood by considering a current-carrying coil. When current flows through the coil, it induces magnetic field. The change in magnetic field in the coil due to the change in current induces eddy current in the metal ring, which induces magnetic field, as to oppose the field generating it. The repulsive force of the south-south pole lifts the ring. In this figure, we have coil wrapped around the iron core, placed over a metal plate. When current flows through the coil, iron core is induced with the magnetic field. This magnetic field as a result induces the magnetic field in the metal, but in opposite direction. Hence, both fields repel each other and iron core is lifted upwards.
Today I'll be discussing on the levitation and propulsion of the train. Magnetic levitation trains float over a guideway using the basic principles of magnets. In magnetic levitation, the magnetized coils run along the track called a guideway. These coils will repel the large magnets on the train's undercarriage, allowing the train to levitate between 1 to 15 cm above the railway. When the train is levitated, power is supplied to the coils within the guideway walls to create a unique system of magnetic fields that pull and push the train along the guideway. The electric current supplied to the coils in the tracks will constantly alternate, causing the change of polarity of the magnetized coils. The change in polarity causes the magnetic field in front of the train to pull the vehicle forward, while the magnetic field behind the train adds more forward thrust. In actual fact, the propulsion and levitation works together in an antagonistically manner. For example, when the train is levitated by the magnets on the base of the train, the propulsive force balances out the train by pushing the train away so that the train is not touching the surface of the guideway.
What allows these trains to move so quickly? Electromagnetism. There are two different systems of magnetic levitation that provide suspension in two very different ways. Electromagnetic suspension, also known as EMS. EMS uses the attractive forces between iron core electromagnets and ferromagnetic rails. Electromagnets that have a current flowing through them are first placed on the underside of the carriage, which creates a magnetic field that is attracted to the stationary ferromagnetic reaction rails that are installed on the underside of the track. This attraction results in a distance of just 10 mm between the stator and the support magnet. The stator is the stationary portion of an electric generator or motor. The carriage is allowed to hover 150 mm above the top of the track. The train is propelled by the support magnets on the carriage, which provides an alternating current that works to create a series of attractive poles and repelling poles. This will eventually result in a forward movement.
Hello everyone! Today I'm going to talk about electrodynamic suspension. When a magnet moves inside a conductor, the magnetic field inside the conductor will change and a current will be induced. The induced current in turn generates a magnetic field which, according to Lenz's law, tends to resist the change that caused the induction. The method of electrodynamic suspension utilizes the principle of electromagnetic induction. The train travels in a guideway which has a series of H-shaped coils on each side. When the train travels by with a high speed, the superconducting magnets on each side of the train will induce a current on the coils. The trick is that the superconducting magnet passes below the center of the H-shaped coils, thus the magnetic flux change in the lower half of the H-shaped coils is greater than that in the upper half, and the current as shown in figure is induced, generating a magnetic force. The magnetic pole in the lower half of the H-shaped coils is the same as that of the superconducting magnet, while the upper half has the exact opposite of it, so that both halves of the coils generate an outward component of magnetic force on the superconducting magnet and levitates the train. Since the H-shaped coils can induce a current and generate magnetism only when the superconducting magnets are in motion, the train cannot be levitated when it is at rest. Therefore, the train first starts by sliding on wheels. When the magnetic force generated is large enough to overcome the weight of the train, the wheels are hit like those of a taking off airplane. This concludes my explanation for electrodynamic suspension. Thank you.
So now I'm going to be talking about the modifications and future uses of magnetic levitation. Scientists have been researching the possibility of inventing a maglev track that could launch spacecrafts into orbit. While the idea may sound impossible, researchers argue that the potential benefits to humanity far outweighs the cost. Its usefulness include defending the Earth against large asteroids, harvesting solar energy, mining raw materials from asteroids, and building space-based industries. The use of magnetic levitation has finally led us to believe the possibility of building flying cars in the near future. So the idea of what I'm drawing right now is that, okay, why am I drawing so slow? is that each private pod, which is suspended from an elevated guideway, can carry 3 passengers and would use maglev technology to reach speeds up to 150 miles per hour. Since there is no burning of fossil fuels, this could reduce carbon dioxide emission and dependence on foreign oil. In addition to that, the Volkswagen hovercar concept also uses the idea of maglev. This car would use cutting-edge technology which could react with the minerals underground to enable its ability to hover. It would have a thruster at the back that propels it forward. Not only that, it is designed with the autopilot feature. It would have voice recognition and would be activated on command. This hovercar would also have the other function, which is the safety sensor. It would be able to move according to the travelling speed and distances to other vehicles and calculate the ideal speed on the road. In efforts to more accurately mimic the effects of drugs or toxic chemicals on real-life tissues, scientists have developed a new laboratory technique in 2008 that uses magnetic levitation to grow cells in 3D shapes. Since then, it has been licensed and commercialized. Compared with cell cultures grown on flat surfaces, these 3D cell cultures form tissue that are more closely resembling those inside of the body. The technique has the potential to drastically reduce the cost of developing new drugs and to reduce the use of animals while testing the safety of manufactured chemicals. Actual hoverboards with the use of magnetic levitation concept is actually invented in 2014. The idea of this board is that it contains liquid hydrogen which cools the superconductors to -322 degrees Fahrenheit and 2 magnets of each end of the board. The board is lifted in a similar way to a maglev train. You may have heard of using a spell to levitate frogs and flies in Harry Potter, but maybe not in real life. However, researchers believe that they can use magnetic levitation on flies to study the long-term effects of weightlessness on humans. Being weightless can have serious health consequences for astronauts. For every month that an astronaut spends in zero gravity, he loses 1 to 2% of his bone density. Muscles deteriorate, fluids redistribute throughout the body, and the immune system becomes weakened. Using maglev to stimulate weightlessness here on Earth, scientists can better understand these changes and their consequences. There is also a possibility that weightlessness can change expressions in genes that are responsible for metabolism, immune functioning, and cell signaling. By understanding how the body reacts to weightlessness, this research could eventually make prolonged spaceflight, such as a journey to Mars, safer for humans. So what I'm drawing right now is a donut. Okay, it's actually not a donut. It is a giant donut, which is floating in the sky and capable of keeping humans alive. So this idea is invented by a Chinese architect, which is a concept entitled Heaven and Earth. It is basically a moving levitated island in the sky, which is complete with mountains, green forests, and urban centers. This architect has justified this concept by equipping the underside of the donut-shaped platform with strong magnets that will repel the Earth's magnetic field. The circular platform can rotate, which generates electricity from their spins, thus creating a completely sustainable society. And this is the end of Group 6 presentation. Thank you for bearing with us.